Mars Inc. says the mix of colors in M&Ms is 24% blue, 20% orange, 16% green, 14% yellow, 13% red, and 13% brown. Assume that the company's claim is true. We want to examine the proportion of orange M&Ms in a repeated random sample of 50 candies. The first one is they want you to graph the population distribution. So that involves all the blues, browns, greens, oranges, reds, and yellows. So the population of blue is roughly 24%. Brown is 13%. Green, 16. Orange is at 20% orange. Red is at 13. And yellow is at 14. And that is your population. B asks you, hey, imagine taking 50 random samples. Make a graph of showing a possible distribution of the same data. Give the value appropriate. So what they want you to do is set this up, and this will be frequency. You go to and what they want you to do is kind of make the same type of graph. But what can it be? Obviously, you're not going to pull exactly 24% blues or 12% browns. So what they want you to do is, hey, give me a possibility and go ahead and make a graph for it. C says which of these graphs could be approximate sampling distribution of the statistic. Explain your choice. Well, the statistic, if we go back up, we want to examine the proportion of orange M&Ms. So that's what we're going to be looking for. So if we look at this first graph is this is the population, meaning we're looking at essentially this is all the colors, but we're just looking for the orange. So I guess this is includes all the colors. This one is centered at, the center's at 0.2, and our orange probability from the population is, we said the probability of orange is 0.2. So good, these two match. So it looks like it could be this one. And let's just go ahead and take a look at the third graph. The center here is at approximately 0.4, but the probability of orange is 0.2. So this does not look like this could be my sample stat. When we describe sample distributions, we're going to do center and spread and all that. And for center, for sample distribution, there's two big things here. And the first one is biased and unbiased estimators. A biased estimator will always under or over estimate. It consistently goes over the expected value, under the expected value, and it never really gets it. Where an unbiased estimator is if the mean of the sampling distribution is equal to the parameter. So that's just saying our samples equal the true population. Spread, you always want low variability. When we're sampling, lower variability will give you just a better insight on the population. So if we take a look at this first target here, notice that this first target, everything is concentrated up here. This has low variability, but it has high bias. Why does it have high bias? Is if this is our center, everything is concentrated up here. There are no points down here or in the left side or up, bottom, far right, or up. So the problem here is this is actually high bias. This second target has low bias because look at how those shots are spread out, but this has high variability because the shots aren't concentrated in one spot. This target has high bias because everything is concentrated up in this region, and this also has high variability because it's pretty spread out. When we go ahead and set up samples, we want to get something as close as this because this is low bias, or rather no bias. Everything is kind of in the center, exactly what we're trying to hit. We're trying to hit our population, and this has low variability because we're trying to hit the center of our target. Histogram above left shows interval in minutes between eruptions of Old Faithful geyser for all 222 recorded eruptions during a particular month. For the population, the median is 75 minutes. We use software to take 500 simple random samples from the population. The 500 values of the sample median are displayed in the histogram to the right. The mean of those are 500 values is 73.5. Is the sample median an unbiased estimator of the population median? So what we know for this is the sample median is 73.5. The population median is 75. Since these two are not equal, it is a bias estimator. It is an underestimator. So for A, it is no. Suppose we had taken samples of size 20 instead of 10. Would would the spread of the sampling distribution be larger, smaller, or about the same? So what happens is, instead of, so we're upping it to size 20. Whenever you increase the size, what happens to the spread? The spread will get smaller. A larger sample provides more precise estimates. Larger samples include more information about the population. It's just like if I only asked the number of truck owners in a city, there's probably fewer truck owners in a city than if I were to go out into the country. So what happens is when we increase our size, the spread gets smaller. The last thing they want you to do is describe the sample distribution, the shape of it. So if you look at this, this is definitely, it's unimodal. And I would say skewed left. Because I would definitely be skiing that way.